Hello guys, my name is Lazaro and today we're going to be doing a medium LeetCode problem. This problem is called rotate list. Given the head of a linked list, rotate the list to the right by k places. So in the first example, we're given the linked list 1, 2, 3, 4, 5, and then we want to rotate it to the right 2 places. So basically, once we rotate it once, this list transforms into 5, 1, 2, 3, 4. And then doing that one more time, we get 4, 5, 1, 2, and 3. So that's pretty much it. Let me actually go over to the other example. This shows us how k could be larger than the length of the linked list. So here the linked list is 0, 1, 2, and then k is 4. Rotating this to the right 4 times, when we first do it, we get 2, 0, 1, then 1, 2, 0, then 0, 1, 2, and then 2, 0, 1. So this will be the answer right here. Now, if you guys know anything about rotations and when the variable they need to rotate by, if that variable is larger than your array or your list or your linked list, you know we have to use a modulo. Because if it's larger, we're only going to be rotating it a certain amount of times before this just repeats. You see what I mean once we get into it. But yeah, other than that, that's pretty much it. It has a short description, 2 short examples. So now we can actually get into the logic of this question. So here we have it. This is a first example they gave us with the head of a linked list of 1, 2, 3, 4, and 5, and then k is equal to 2. So the first thing you guys want to do is we want to know the length of this linked list. The reason why we want to know the length is because if we know the length, so right here we know the length is 5. If we know the length, then if we could do 5 minus 2, we get 3, which is the same thing as length minus k. That will give us 3. What this 3 represents is how many nodes are going to be at the end of the answer. Remember, the answer for this question is going to be 4, 4, and then 4.5, and then 1, 2, 3. This is the answer. And this 3 represents the first 3 nodes, which also represents the last 3 nodes. The reason why we want to know that is because this could become useful. Since k is 2, then we know that the last 2 nodes of this linked list, so right here, is going to be in the front. So with that length, we can do that computation, and then we can kind of just swap it, and we get our answer. It's really this simple, to be honest with you. This is how much the length, just getting the length of the linked list can take us. But there's a couple of other things we should look out for. So let's get back to what I was saying about the modulo using k and then use the length. If we know the length, something else that we could do is bring down our k. If k is larger than our linked list, then it's going to get to a point where we just start from the beginning. So instead of, let's say here k, instead of it being 2, if this was 8, then we're going to be pushing this to the right multiple times. The first time is going to look like this. 5, 1, 2, 3, 4, and that's it. Then the second time, it's going to look like this. Then I'm fast forward and then just fill out the other ones until I get to the place that I want to show you guys. Okay, so here we have it. Here I went and wrote out each and every single step if k was 8 and then our linked list was this head linked list right here. Now, as you can see, it gets to a certain point where at step 5 is exactly equal to what our linked list was in the beginning. And the reason for this is because k is larger than the length of our linked list. And if it's larger than, then it's 100% positive that at a certain point, we're going to be rotating it and it's going to equal to what it was in the beginning, like it was right here. And that's because it's just larger, it makes sense. So the real amount of rotations we actually did is 3. These right here, these don't count because they just lead to what we had in the beginning. So these we can just knock out. So the actual number that our k is supposed to be is 3, not 8. But how do we get that 3? Well, we get that 3 by using the modulo operator. If we do k modulo length, which turns into 8 modulo 5, how many times can 8 go into 5? Well, once. If k goes into 5 once, then we will have a remainder of 3. And this is exactly the number of actual rotations we do. So this is why we want to use the modulo. Using the modulo, it knocks out some extra steps or extra rotations that we don't really need to do because it will just be useless. So we have to use this as well. And as you can see, this takes in the length, which is another reason why finding the length of this linked list is so important to answer this question. All right, so now let's just continue. Let me rewrite the linked list. And hopefully by now you guys understand why we need the length and why we need to take the modulo of k modulo length. All right, so this is our linked list. Now, since we know the length and we know if we do some extra math, if, for example, we do length minus k, this will turn into 5 minus 2, and this is if k is equal to 2. And this will just give us 3. And then 3 is going to land us right here on this node. Well, it depends on how you're counting. 3 can also land you here. But here, let's actually do k minus 1, minus 1, minus 1, that's 2. So now, if you're starting off from 0, if you start off from 2 and then you finish at 0, you should be landed right here. Because here, k will be 2, and then here k will be 1, and then here k will be 0, and that's where the for loop or your while loop would end. So if we're on this 3 node right here, we know that everything after is will be the beginning of our answer. These 2 are the nodes that we need to rotate. But rotate is basically just taking these nodes and adding it to the beginning to get 4 points 5, and then 5 points to 1, and then this is our answer. But there's a couple of other steps we need to take care of first. First off, let's save these 2 nodes in a variable. Let's call this variable pivot. Okay, let me just erase this up here. Cool. Now that we have these 2 nodes in a variable, we can use them later. Now what we want to do is, here, let me bring this down here. This is in a variable called pivot. Awesome. Now what we want to do is, since we're at this node 3, which is the end of our answer, that means that this 3 needs to point to nothing. It needs to be the last node. So we need to change the next of this 3. Instead of pointing to 4 and 5, let's just make it point to nothing. So let's cut this out. Then what we can do is we can save these nodes in another variable. And since we're going to be passed in a parameter called head, and since all of these nodes are point to the same address in memory, then head changed from 1, 2, 3, 4, 5 to just 1, 2, and 3. And now you guys might know what is coming, but basically all now we need to do is we need to get the last node in our pivot linked list, which in this case is 5. And we need to make 5 point to whatever head is. Once we do that, then we get we're left off with 4 points to 5, and then 5 points to head, which is 1, 2, and 3. And this is the answer we're looking for. So it's really that simple. It's basically go to the node that's right before the nodes that will be part of the pivot, or the nodes that will be shifted to the right or rotated to the right k times or k places. Go to that node, which in this case is 3. Make everything else, aka the nodes that are going to be rotated by rotated k places, save that in a variable, save those nodes in a variable, and then update what 3 points to. So update it and make its next point to nothing. And then just rearrange this order. So inside of the nodes that are going to be rotated k places, make the last node point to the nodes that were not rotated. Now hopefully this isn't too confusing, because you do need some solid understanding of how linked lists work for this. But now, since I just explained it, let's get into the code, and while I'm writing the code, I'll talk about it a little bit more. So let's first get the length of our linked list. I'm going to create a dummy variable and name it head, and then I'm going to create a length variable that's initialized to 0. So dummy, I have a dummy variable, points to head, which is the linked list, and then a length variable which has a length of 0. Now, while the dummy is not null, so while it's actually on a current node and not a none node, then we want to increment length by 1. And then we want to go down the linked list, so we set dummy equal to dummy.next. And then with this right here, we will get the length of the linked list. But now we want to insert an if block. So if the length is equal to 0, or the length is equal to 1, or k is equal to 0, we just want to return the head. Because if there are no nodes, there are 0 nodes in the linked list, then there's no point for us to do any work. There's no nodes, there's nothing to rotate. So let's just return head. Also, if the length is just 1, if there's only 1 node, then no matter how many times we're rotating, it's not going to make any difference in the linked list because it's just a single node. Or if we have to rotate the linked list 0 times, well, that's the same thing as never rotating, So we just return the head. Now we can do our computation where we take k and take the modulo of k with length. And here we want to insert another if block. If after doing this computation, if k is equal to 0, then we can just return head as well. So if the length was 5, if the length of our linked list was 5, and k was also 5, then we know that at the end of the day, we will do no rotations. We'll be left off with the same thing. Well, we'll do 5 rotations, but at the end of doing those rotations, we're going to end up with the same linked list. So you could have also added this here and done something like or k is equal to length, but I'm just going to add it here separately. Awesome. So now we're going to want to create that pivot variable and initialize that to head. Then we want to find the difference. We want to find the last node before we start getting to the nodes that are going to be rotated to the right k places. And at what position is that node? Well, we can find it using the length. So here is v5, as you can see right here in this example, minus k. Since here k is 2, 5 minus 2 is v3. But we also want to do minus 1. The reason why we want to do minus 1 is because I'm going to be using a while loop. So while difference is not 0, then let's decrement it by 1. And let's set pivot equal to pivot.next. So what is this doing? Well, let's first get down to this formula right here. Length minus k minus 1. Here our length is 5. K is 2, so 5 minus 2 is 3, and then 3 minus 1 is 2. Difference is equal to 2. So while difference is great, it's not 0, aka it's a truthy value, then let's decrement it and set pivot equal to pivot.next. So let's work through this example. Here, pivot is set to head, which is 1. So we're currently on 1 right here. Now let's get into our while loop. Difference is set to 2. And then it does 2 minus 1. And then it moves pivot. So now pivot goes from looking at the 1 node to the 2 node. And different goes from 2 to 1. 1 is still a truthy value. So this while loop runs again. 1 minus 1 is 0. So now diff is 0. And then pivot is going to equal to pivot.next. So I'm going to go from the 2 node to the 3 node. But remember, difference changed from 1 to 0. Therefore, our while loop terminates and it does not run again, because 0 is a falsy value. So when this while loop finishes, I'll be left off on 3, which is exactly what we want, because 3 is the last node of our answer right here. And if we do 3.next, it's going to give us 4 and 5, which are the nodes that are going to be rotated. As you can see right here in the answer, 4 and 5 is in the beginning because it got rotated to the right 2 places. So now that we have that info, we know that the start, aka the start of our answer, is going to be equal to pivot.next. So that 4 and 5 is now set to start. Or start points to this 4 and 5 linked list. Now we want to clear what pivot points to. By doing pivot.next, that means now that head changes from 1, 2, 3, 4, 5 to just 1, 2, and 3. Because since pivot was 3, pivot.next is going to be this 4 and 5 linked list. But since we changed pivot.next equal to none, then head is just 1, 2, 3 now. So cool. Now we know that head is 1, 2, 3 and that start is 4 and 5. Now we just have to put them together, make sure start is put first and then head is put second, so we can get that 4, 5, 1, 2, 3 answer. To do that, we're going to want to set dummy equal to start, and then while dummy.next, we want to move dummy. Because remember, since this is 4 and 5, since start is equal to 4 and 5, if I were to do start.next is equal to head, my answer would return 4, 1, 2, 3. And we don't want that. The only next we want to change is of the last node that we rotate. And the last node here is 5. So we first have to get to that 5 node. And we do that, we're using this while loop. So dummy is equal to start. What is start? Start is 4 and then 5. But since start first looks at 4, we're on 4. Now we get into this while loop. While dummy.next. Well, while 4.next. Does 4 have a next node? It does. So the while loop runs. Now it sets dummy equal to dummy.next. Since dummy is 4, 4.next will give us 5. So now dummy is equal to 5. Now, does 5 have a next node? It does not. So the while loop terminates and we're left off with dummy pointing to just 5. And so since we point to just 5, what we can do is dummy.next is equal to head. So now 5 points to 1, 2, 3. And if you remember, start pointed at 4. So now start is equal to the linked list 4, 5, 1, 2, and 3. And with that, we can just return start. And now let's run our code, see if I made any typos, and it works. And if it works, which it does right here. So now let's submit it. And it gets accepted. Perfect. So hopefully you guys enjoyed this video. Oh, I do want to say that the space complexity of this answer is big O of 1. We only used numbers. We didn't use an array or a dictionary where we add to. So space complexity is big O of 1, constant. And then time complexity is going to be big O of n, linear. Because we still need to iterate through the whole linked list. Alright, so hopefully you guys enjoyed the video. If you did, leave a like and subscribe. Also, if this interests you, join our Discord server where we send out both beginner and advanced problems every single day. Other than that, thank you guys for watching, and I hope you have a good day.